So up here at the top of the paper, we evaluated piecewise functions when given a function. Now we're going to evaluate a piecewise function when we are given a graph. Now, we are not asked to write the equation of these piecewise functions. And if we did, let's just go ahead and state the obvious. Here we'd have 3 pieces. Here we'd have 2. On some of the other ones we'd have, well, it depends on the problem itself. But okay, here's the deal. What we're going to do is find out the value of the function, and we're going to go back to some old Math 1 stuff that you learned where if you have an open circle, it doesn't exist. So here goes. F of negative 6. Okay, this is the x value. So here's what I'm going to do. I'm going to find out what the y value is at negative 6. So 1, 2, 3, 4, 5, negative 6. And then I slide up, and it's right here. So wherever here is, whatever the y value is here, and it is 7. And it's that easy. But it's not. Okay, f of 0. So again, 0 is the x value. So this is saying, what is the y value when x is 0? This is exactly what was happening here. What is the y value when x is 2? Well, the y value would be negative 3. If I graphed it, I'd have a coordinate at 2, negative 3. Okay, well, now I do have a graph, and I can find it pretty easily. So f of 0, 0, I'm going to go up until I see the graph. Well, here's the problem. Do I count this one or do I count that one? Well, if it's an open circle, it does not include it. So no, don't count this one, but yes, count this one. So it is 3. The y value is 3 when x is 0. F of 2, 2. And then I go up until I hit the graph and I get a 4. F of 4. Okay, I go over to 4, and then I look at this and I say, well, is it this one or is it this one? No, don't count the open one. That means it doesn't include it, but I will include this one. It's a 5. And then f of 5 is on this parabola, this little piece of a parabola right here. And I look at that piece of the parabola and I say, well, what's the y value? And the y value is, well, it's sitting on the x-axis, so it's 0. It corresponds to 0. There we go. And it's really that straightforward. All right, so let's keep going. F of negative 4. So we go to negative 4. 1, 2, 3, negative 4. We go up and we get 5. No secrets there. F of 0. And I go to 0 and then I look and I don't see the function graphed anywhere. I'm moving my pen up and down and I don't see the function graphed at all, which tells me that the function is not defined at 0. So I'm going to write undefined. F of 3. I go over to 3, and it's here. It's at negative 1. F of 6. I go over to 6. I go down 1, 2, 3, 4. There it is. It is at y equals negative 4. Okay? So I'm going to go through the next page. They're pretty straightforward. Feel free to pause this, mute this, do whatever you need to do. Try some of these on your own. I'm going to keep going. F of negative 3. 1, 2, negative 3. We're going to go up till we hit the graph, and we hit the graph right here at y equals 8. F of 0. 0, negative 1. F of 2. 1, 2. Okay. Now again, don't count that open circle. It's that one. It's that dot right there. That dot is at y equals 1. And then F of 5 goes over here. F of 5 is 3. There it is. Okay. I do want to sidetrack here for a moment, and I do want to do something that it didn't ask us to do. But let's write the equation of this piecewise function, because I think this is a really good one just to wrap our mind around and see what's really going on here. So it's a good practice. I wonder how many pieces there are. Well, here's 1. There's 2, and it looks like just 2, but actually there's a third one. There's that one little dot right there that's its own. So here's the first piece. This first piece is a parabola. Standard parabola, not too skinny, not too wide. It's basically just x squared. And it got shifted down 1. And this is true for all the x values that are, all right, hold on, let me grab a post-it note here. It's true for all these x values right here. So from negative infinity all the way to 2. Okay, cool. So basically everything that is less than, but not equal to 2. And it's not equal because at the end of this parabola, there's an open circle. Okay, I'm going to jump to this next piece, and the next piece is a little more obscure. It's just this dot. And this dot is not a line, it's not a parabola, it's a dot. It's a point, it's a location. And this location is, well, when I say location, I'm referring to a coordinate, and the coordinate is 2, 1. So it's for every x that's equal to 2, and the location itself is 1. It's not 1x, it's not anything, it's 1. It's a coordinate, 2, 1. Then this piece right here is the line y equals, well, 3. It's just 3. And you might say, well, it's not just a dot. I agree with you. It's not just a dot. It's a line because it's everything that is greater than, oh, it's going to get tricky. I about wrote it wrong. It's everything that is greater than x equals 2 and everything less than 5, and actually including 5. So it's stuck between 2 and 5. So let's write it like that. Let's write it as being crammed between 2 and 5, and then we'll pause here and try to figure out which one of these is equal, if either one of them are. So we'll see, for this piece right here, it is not equal at x equals 2. It is equal at x equals 5. So we have done that they did not ask us to do when we wrote the equation. Good for us, but it was a good little idea. Nice little practice to do that. We might do that on one more. We'll probably do it on number 17. It's just a good idea to try it. Make sure we know how to bring everything together in our talk about domains and translations and things like that. Kind of brings it all together. Okay, so f of -1. F of -1, let's go back. We go up, and it's equal to 1. F of 0 is down here. Oh, no, it's not. Not the open circle. It's the closed circle. It's -4. And then f of 3, 1, 2, 3. We go up till we hit the graph, and we hit the graph at 1. All right, here we go. Let's keep moving. Let's actually go ahead and write the equation to this one, just because it's fun. We'll do it kind of quickly. 3 pieces to this: horizontal line, parabola, and a dot. So horizontal line has an equation of, well, don't think too hard. It's just -3. And that is true for all the x values from here to here. So from -3 to +2. So -3 to +2. Let's figure out which one's equal. So, yeah, closed circle at x equals -3. So we fill it in here. Open circle at 2, so no, not here. Okay, we do this. We come to the next piece. You might think it's the parabola. Technically, it's this one. And that is true where x equals 2. And that location is simply the y value of 3. And then this piece is a parabola. And this parabola exists for all x values greater than, but not equal to, 2. So here goes, x is greater than 2. And this is a standard parabola. When I say standard, meaning it's not standard form necessarily, but standard in terms of just general basic shape. It's not too wide, not too narrow, which means its leading coefficient is 1. Technically, its leading coefficient is -1. And it has a horizontal shift of 3, +3, which means we're going to go x minus 3 in there. Okay, there we go. That was fun. Let's keep moving. F of -4. If I want to know what the y value is at -4, I go to x equals -4, and then I look, and oh, it's not there. So it's undefined. The function is undefined. We could say, let's not say no solution. We're not technically solving anything. We're talking about the value of a function, and it is not defined, so it's technically undefined. Okay, f of 2. We go over to 2. We go to the closed circle, which would be at 3. F of 4. 1, 2, 3, 4. And we will go till we hit the function, and we go down 1. Whoops, move the paper. Down 1. All right, one more problem in this section. F of -1. We go back 1. We're going to go up till we hit the function. We hit the function right about 9, it looks like. I think it's right at 9. 0. We go to y equals 0, x equals 0. We go up till we hit the function. The y value is 5. At 1, oh, now it gets tricky. I like this problem. It's one reason I put it in here, if my memory serves me correctly. F of 1. Well, I'm going to go till I see the function. I don't have a choice. I don't have a function. Now, don't say, well, what about that circle? That's the only one I have, so the value must be... No. No. Undefined. There is no function at x equals 1. It ceases to exist right there. And that open circle means that I cannot count that. And then at 5, we go over to 5, and then we'll go till we hit the function, which is down here. And that is a closed circle, so we can count it. That's at -9.